We know more about Mars than we do about this place. A world so deep, so extreme, that if you fell in, you would be crushed before you even reached the bottom. But what if we could do the impossible? What if we drained the Mariana Trench, the deepest, most mysterious place on Earth, revealing what has been hidden for millions of years? Would we uncover lost civilizations, undiscovered creatures, or forces beyond our understanding? Or would we unleash something that was never meant to be disturbed? Let's find out. Introduction to the Mariana Trench. Imagine you're floating in the middle of the Pacific Ocean, nothing but endless water in every direction. But beneath you, hidden under miles of crushing darkness, lies something so deep, so extreme, that we know more about the surface of the moon than we do about this place. This is the Mariana Trench, the deepest place on Earth. A world so far removed from ours that it might as well be an alien planet. If you could drain the ocean away like pulling the plug on a giant bathtub, what you'd reveal is a gash in the Earth's crust stretching nearly 1,600 miles long, longer than the entire US West Coast. And at its deepest point, the Challenger Deep, the ocean floor plunges down nearly 36,070 feet, 10,994 meters. To put that into perspective, if you placed Mount Everest inside, its peak would still be buried under more than a mile of water. But this isn't just a hole in the seafloor. It's a battle scar of our planet's violent geology. The Mariana Trench exists because the Pacific Plate is being forced beneath the Philippine Sea Plate, a slow-motion collision that has been reshaping Earth for millions of years. Down here, the pressure is beyond comprehension. Over 1,000 times what we feel at sea level, like the weight of 50 jumbo jets stacked on your shoulders. This crushing darkness is so inaccessible that fewer than 20 people have ever reached its deepest point, fewer than the number of astronauts who have walked on the moon. In fact, we have more high-resolution images of distant planets than we do of the Mariana Trench's floor. So if we could somehow drain it, exposing what has been hidden for millions of years, what would we find? Would it be a silent graveyard of ancient creatures? A landscape shaped by forces more powerful than anything on land? Or something else entirely? Something Earth has kept buried for a reason. The impossible drainage. Before we even begin to imagine what lies at the bottom of the Mariana Trench, we need to acknowledge one simple fact. Draining it is impossible. We're talking about a trench that holds trillions of gallons of water. To put that into perspective, if we use the most powerful water pumps on Earth, the kind used to drain entire lakes or flooded cities, it would take millions of years to empty. And even if we somehow built the largest pumping system ever conceived, where would all that water go? Dumping it onto land would drown continents, and releasing it into the atmosphere would disrupt weather systems beyond recognition. But let's push reality aside for a moment. What if we had technology far beyond our current capabilities? Picture a network of gargantuan pumps the size of skyscrapers, sucking up water at an unimaginable rate. Or maybe we tap into pure science fiction, vast portal technology that instantly teleports the trench's water somewhere else, perhaps into space or another dimension. While these ideas are fun to imagine, they highlight just how mind-bendingly difficult this task would be. Instead of draining it all at once, let's break it down into stages. Suppose the water level gradually drops, revealing layer after layer of a world unseen by human eyes. First, the shallower depths dry out, exposing strange, deep-sea creatures desperately struggling to survive. As the descent continues, hydrothermal vents, normally hidden under crushing darkness, stand like ghostly towers, releasing steam into the open air. Further down, the true depths of the trench come into view, a place where pressure once strong enough to crush a submarine has now vanished. The exposed seafloor begins to crumble, unleashing unknown consequences on Earth's geology, atmosphere, and climate. This isn't just a thought experiment, it's a way to understand the delicate balance of our planet's systems. The Mariana Trench isn't just an abyss in the ocean, it's a pillar of Earth's stability. And if we were to remove it, we might not just be draining a trench, we could be unraveling the planet itself. For a moment, let's assume that we can drain this trench. What will be the results? The immediate effects. Draining the Mariana Trench isn't just about revealing what's hidden beneath miles of water, it's about unleashing forces we were never meant to witness. As the last drops vanish, the sheer scale of the exposed trench would be overwhelming. Imagine a canyon so deep and vast that even standing at its edge, you'd struggle to grasp its enormity. This is a place where light has never touched, where creatures have evolved in complete isolation, and where the very fabric of Earth's history is written in untouched layers of rock and sediment. At first, it would be a geologist's dream, an untouched record of Earth's past, perfectly preserved. Towering cliffs of ancient rock would reveal the scars of deep-sea earthquakes and tectonic shifts, while hydrothermal vents, once billowing clouds of minerals into the deep, would now spew directly into the open air, releasing gases never meant to mix with our atmosphere. The seafloor itself would be a bizarre alien landscape, sharp ridges, volcanic craters, and mud volcanoes stretching for miles, like a lost world frozen in time. But this moment of discovery wouldn't last. Without the crushing weight of water, the trench walls would begin to shift. Entire mountains of rock, once held stable by immense pressure, could suddenly collapse in on themselves, sending landslides cascading down the abyss. And then, there's the atmosphere. Gases trapped for millennia within deep-sea sediments would begin to escape. Methane, a greenhouse gas far more potent than carbon dioxide, would surge into the air, potentially triggering unpredictable climate shifts. What we've revealed is not just a hidden world, it's a delicate, dangerous balance that was never meant to be disturbed. And we're beginning to understand the consequences. Biological catastrophe. The moment the trench is drained, its ecosystem, one that has existed for millions of years in complete isolation, faces total collapse. Life here isn't just unusual, it's uniquely engineered for an environment unlike anywhere else on Earth. Creatures like the Mariana snailfish, which can withstand pressures 1,000 times greater than at sea level, would be obliterated within seconds. Their bodies, adapted to an existence where the crushing weight of water is a necessity, would rupture and implode as soon as that pressure disappears. But the devastation isn't limited to individual organisms. At the very bottom of the trench, hydrothermal vent communities depend on a process entirely different from photosynthesis, chemosynthesis. Here, bacteria convert toxic chemicals into energy, forming the base of a food chain completely cut off from sunlight. With the water gone, those vents become nothing more than exposed, superheated rock, killing off the bacteria in an instant. Without them, entire species, giant tube worms, deep-sea crabs, and ghostly translucent fish, vanish overnight. And the chain reaction doesn't stop at the trench. The deep ocean isn't a stagnant void, it's a crucial component of the planet's ecosystem. The sudden disappearance of trillions of gallons of water would send shockwaves through global ocean currents. These currents, responsible for redistributing oxygen and nutrients, are the lifeblood of marine ecosystems worldwide. Coral reefs, fish populations, and even whales that depend on deep-sea upwellings for food would suffer, leading to mass die-offs across the planet's oceans. This isn't just the destruction of a single habitat, it's the erasure of an entire evolutionary lineage. Creatures that have survived since before the dinosaurs, thriving in the most extreme conditions on Earth, would be gone forever. Atmospheric and climate consequences. Draining the Mariana Trench wouldn't just reshape the ocean, it would disrupt the very systems that keep Earth's climate stable. The moment the water disappears, an invisible chain reaction starts in the atmosphere. First, let's talk about gases. Deep-sea water traps large amounts of dissolved carbon dioxide and methane under immense pressure. When suddenly exposed, these gases would escape into the atmosphere, leading to a short-term spike in greenhouse gas concentrations. Methane, in particular, is over 25 times more potent than CO2 at trapping heat. Then there's the immediate impact on humidity. The sudden loss of trillions of gallons of water means massive evaporation from the surrounding ocean to compensate. This would drive a sharp increase in atmospheric moisture, fueling more extreme weather events. More moisture in the air doesn't just mean heavier rainfall. It means supercharged hurricanes, larger typhoons, and an overall increase in storm intensity. But the bigger issue is global air pressure patterns. The Mariana Trench plays a crucial role in the Pacific Ocean's thermohaline circulation, the system that moves warm and cold water across the planet, regulating climate. Removing such a deep, dense mass of water would alter ocean currents, weakening or even collapsing key circulation patterns like the Pacific Decadal Oscillation. Without these currents distributing heat, some regions would face extreme warming, while others could be plunged into colder than normal conditions. And this isn't just theoretical. We've seen similar effects in real life. When the Atlantic's Gulf Stream weakens, Europe experiences colder winters, while hurricanes in the Atlantic become more frequent and intense. A disruption on the scale of draining the Mariana Trench would throw the entire system into chaos, potentially triggering long-term climate shifts far beyond what we've already seen due to human-driven climate change. So while it's easy to imagine the exposed seafloor as just a massive canyon, the real story isn't what's below, it's what happens above. The atmosphere would respond in ways we can't fully predict, but one thing is certain: removing the trench would mean rewriting Earth's climate as we know it. That's all for today. If you have enjoyed this video, don't forget to show some love by hitting that like and subscribe button.